Does it work? This mic. Well, nevertheless. I'm also a master student at the University of Bolzano, and yeah, today I'm going to do an introduction to the Go programming language. It's not going to be an introduction to programming, so I expect you to know something about like development and the basics of computers. Yeah, and okay, let's get into it. I want to like to give me some kind of authority over why am I speaking in front of you. So I searched our GitLab server and like I was trying to find the first project that we did. Keep in mind using Go, so to know from how many years we have Go in production. And it turns out it's from January 2018, and we have this Scatter Uploader project that has been running ever since. I also wanted to share with you while I was searching the Git history, I also found my very first commit. And look at that title. It's like, I don't know, maybe I was thinking like Git, it's a personal note, a personal diary or something like that. Yeah. This is how we will spend this 1 hour and a half, roughly. So in the first half an hour, something like that, we will have a look at the history of Go, really a sneak peek of that. Then I wanted to like give you some reason to learn Go, because at the end, even though I'm presenting you a very nice language, if there are no cool projects written in it, like it's useless, right? So let's have a look at some real-world projects. Then I wanted to have some hands-on to show you some code, some Go code. Afterwards, we will have an open discussion. At least it's supposed to be like that. And I prepared also something for that section. So maybe if we avoid staying here and looking at each other's eyeballs. So let me begin with the first section. So Go has been released to the public in 2009, and they've started working on it in 2007. I didn't know nothing about Robert Zimmer. I don't know, it's from Switzerland. Maybe you know how to pronounce its name. And Rob Pike and Ken Thompson. Ken Thompson is the one of Unix. I found while I was like looking of this history, I found the official promotional video, and I wanted to share it with you because I think it's really what they state there. It's the least interesting features that I like of the language. So it's 1 minute, and yeah, I think it's worth watch.
Hi, my name is Russ Cox, and I'm a member of the Go team here at Google. Go has many interesting features, including built-in support for concurrency and a novel type system. But one of the main reasons that I enjoy programming Go is that it's just plain fast. Most of my builds when I'm programming take well under a second. Let me show you. This is the math package with implementations of things like sine and cosine. There's over 1,000 lines of Go and about 20 files. If we build the whole package, it builds in about 200 milliseconds. We can also run the tests for the package, which rebuilds the package including the test functions and runs it, and that runs in well under a second. This is the whole Go package tree. There's about 120,000 lines of source code, and we're going to build the whole thing. The package tree includes flags and regular expressions, and the math library, and formatting library, an RPC package, a full parser for the Go language, and many other packages. And there, it's built in under 10 seconds, and that's just running on one machine, my laptop. When builds are that fast, I can get a lot done in a day. Go is a fast, fun, and productive language. We hope you'll try it. There's more information and downloads available at golang.org.
So I think Go is plenty of cool features, and these are the least ones I'm interested in. So today we are not going to talk about Go's performance and everything, even though it is one of the interesting topics. and it is one of the things that they wanted to introduce to use in the to show the promotional video. So some notable projects written in Go. I would like to know how many of you know what Docker is. Like, okay, pretty much everyone. And how many of you knew that Docker is written in Go? None of you. Ah, cool. So in 2013, they started writing Go. I have 3 projects now. Can I drop this thing? Yeah. Okay, thank you. So I have here 3 projects, and I just searched the internet to find what the employees of these companies think about the language, why they picked Go. And I wasn't surprised by their responses. For example, this Docker employee, they said that they started writing Docker in Python, but then eventually they had to drop it because I think it's the reason they built Docker in the first place. You want to deploy things that are reproducible. Like I write something in my development environment, I ship it, and it runs like in development. And so Go has this feature. So basically, you compile shit and stuff, and you deploy it into the server, and it bundles everything within. Another project. So let's do the game again. How many of you know about Prometheus? Ah, none of you. Interesting. So Prometheus is a solution. It's in the cloud foundation. I don't remember. But it's basically you run the server and you use it to collect metrics, usage metrics and stuff. So usually you deploy a server and then that server exports some metrics in the standard, in the format they have defined, and then Prometheus is going to scrape these metrics and collect the time series and then export them again, allowing you to attach other tools like visualization tools or other things. And this project is written in Go as well. There in that post, they were interested in the one of the features they liked. It's that Go is fast. But yeah. And what about Terraform from HashiCorp? How many of you know about it? Okay, cool. And how many of you know that it is written in Go? Ah, interesting. So yeah, Terraform is as well written in Go, together with all their projects. So HashiCorp writes only software written in Go, basically. And one of the creators, of the founders, I extracted this comment that I think it's really, it gets to the point. He thinks that a lot of issues that you find when you deploy tools like that in Python, it's the runtime. You are working on one runtime on your machine, you deploy your product, and then eventually something happens badly in the customer's machine because of the library, the Python version, the operating system, and it is pretty difficult for us developers take care of these issues. So Go instead focuses that. Let's move to the third section, which is a tour of Go, because right now I just thrown at you the features of the language, why they picked Go and something like that, but we don't know yet anything about the language itself. So I tried to condense the features I like the most about this programming language. So Go is statically typed. So it means that at compile time, like the compiler is going to assign to each variable a type. And then at compile time, it's going to make sure you're actually using those variables in the way you described. So you don't have any runtime surprise because of the types. Go is also statically linked. What does that mean? It means that at compile time, every dependency, every library is bundled into the final binary that you are linking. So this is opposed to dynamic linking, where like your binary describes the libraries that you want to have at runtime, and when you execute the binary at runtime, it's going to like look into your system if you have the compatible library version. So dynamic libraries came into place to avoid having like a repetition of the same libraries of the same binary code inside your machine. But eventually they lead to many problems, and Go creators just dropped the idea and prefer to have larger binaries that bundle everything with them. Another feature that I really enjoy about Go is native cross-compilation. So not only we statically build the executable so it contains everything with that, we can cross-compile this binary for other machines right inside our laptop. For example, let's say I'm working on some project and I want to share it with my friend that has a Windows machine. I can just select the Go OS Windows. Let's assume that the architecture of the target machine is the same as mine. Otherwise, I can use GoArch to change that. Let's say it's Linux and the machine is running on IRM chip. So I just have to declare these two things, build as usual, and the output binary will be like a static binary. Everything is going to be in it. I just have to send it to him, he's going to run it, and yeah, everything is going to work as in my machine. Go is also garbage collector, as a garbage collector. So I wouldn't say that Go is a language with automatic memory management all the way along, because you have to take care of allocations somehow. Sometimes it's more implicit, but other times it's really explicit, how much space you allocate, for example, for slices or arrays. But then you don't have to take care of freeing the memory. The runtime is going to take care of that for you. Go has concurrency built in. So there is a difference, a deep difference between concurrency and parallelism. For now, let's take it as it is. But later we have time for questions and stuff. So if you have problems with that, we can talk about it. So Go provides Go routines for running functions concurrently between each other, and a native mechanism for synchronizing them, which are called channels. They look like a message passing interface, but it actually is like a shared memory. You will see later on. So these were just the features. Now we have some milestones that I think we have to reach before having a proper conversation in Go. My objective here, just to state it, is after this session, I hope you will be able to read Go code, to open a repository in GitHub and understand it. I would like you to be able maybe to clone the repository and know where things start, how to build the thing, and stuff like that. So through these milestones, I will skip a lot of things that I think you as developers will be able to like get and understand and learn in minutes, just opening the internet. So this is going to be a little bit fast. But please, if you have any questions like that, the code that doesn't make any sense to you, stop me and I'll repeat it. I'll just find another way to explain it to you.
Yeah, sorry for the short-sighted people. If it's possible to increase.
Let's try that. It looks like it is refusing to increase the size even more. You're going to. I think it is better that you come closer if you don't really see, because I don't know how to increase the font. I'm really sorry. This is not my usual presentation program, but this one has a built-in Go playground. So we actually have a chance to run the code we see and play with it. So I beg your pardon if the font is not really readable. I don't know how to increase it. So this is the anatomy of the. In this program, we already see a lot of things. So every Go file has a package declaration, So Go code is wrapped in packages. A package, each folder in your file system can only contain at most 2 packages. The package one, like the main, for example, or the format package, and its testing package, like format underscore test. It cannot have more than that. Go code that does something useful also imports code from other packages. So you always find at the beginning of the file an import statement and a list of packages that your code is importing. Afterwards, you can use, as you can see in the main function, the package dot the exported function. Yeah, I used the emoji because every Go file is a UTF-8 encode. It's supposed to be an UTF-8 encoded file. So it is legal to use emojis and stuff like that everywhere. Yeah. So let's move to the second one. Please stop me if a milestone is not clear to you. So we said that Go is statically typed, so the compiler is going to infer each variable which type does it has. This is the simplest way of declaring a variable. Use this column equals operator, and this basically states that the compiler has to infer the type of the variable based on the value on the right-hand side. In this print statement, I'm using the v verb and the t verb.
Can you try with this
Yeah.
one?
Whoa. Hello. Whoa. Do you all listen it like if you?
He's a bit louder.
Yeah.
Is it possible to get? Yeah.
Is it?
Maximum?
Hey.
The volume
Hi.
is at the maximum.
Okay. Whoa.
You have just to scream.
I'm silently dropping it. Okay. So in the this t verb is going to display the type of the variable, and v is going to show you a representation of the value. So let's see what the compiler understands about that. So it shows something, and the type is string. Let me change something with like a 3. That's not a code, so that's an integer. If we make it something like that, it's a floating point. And let's see if I can do something more complex. Yeah, that's a complex number. And we can also, I don't know, we can have each, whatever value we want on the right hand side of that operator, okay? And the compiler is going to infer the type for us. All clear? Okay. So this is the third milestone. Go as functions. As we saw at the beginning, when we use the println function, so we can use a function which lives inside the format package. We are allowed to call that function because it is visible to us, because it is exported. And Go uses a very simple, I think, mechanism for detecting, for allowing you to choose which functions are exported and which ones are hidden. And it is the very first letter of the function name. So add more in this case as a lowercase a at the beginning. So it is not going to be visible outside of this package, this folder. Instead, add is going to be exported outside of the package and visible. Here you also see another feature of Go. It allows you to declare functions with a variadic number of arguments, but it doesn't allow you to do function overloading. I don't know if you know what that is. So you have a function with the same name and different arguments. You cannot do that. You can have just one function with one name, but you have variadic numbers. Here you see the second way of declaring a variable that you have in Go. So there is this reserved keyword var that you can use to declare variables, and then afterwards assign something to them. these variables, you are ensured by the compiler that they will hold the 0 value of that type. So if, for example, and it is declared, which is the 0 value of each type. For example, int, if you declare an int, the 0 value is 0. Yeah. So add will start, result, you are ensured that will start with 0, and you add the numbers, and yeah, that's it.
For string, it's null.
For string, it's the empty string. For pointers, it's null. I tried that already. It refuses to. Yeah, I'm really sorry. I don't really know how to cope with that. Yeah. So just to show you the Varnadic thing, we can add more parameters in there, and yeah, add more. It's going to take care of that. You also see maybe here something that it's really different from other languages, or at least I think Go resembles a little bit C syntax, but they use types at the end. So C has this circular way of understanding which type has each variable. Instead here it is from left to right. You have the name and then the type. The function is the same. You see you have parameters A, B, which are of type integer, and the function returns an integer. Okay. If you are good with that, we can go to the fourth milestone, which is error handling. And this is one of the parts I prefer the most about Go. Go doesn't have any special thing to cope with errors. Error is just a type. It is actually an interface, and we will learn about that later on. So this is how you really cope with errors. Functions can return multiple types, and usually if your function is supposed, or at least it may happen that it returns an error, you can just add that to the list of the return values. So in this case, this openTemp function is going to return an os.file pointer. Oh, this was a sneak peek. And an error. So yeah, this is code you will see if you start writing Go code. This is what you will see a lot of times. And so you call a function, see return values, and you check for errors. If there is any, you do something. In this case, we are just printing it and exiting. That's it. You also have the panic function, which is going to panic, pretty easy. But this is not something you are going to write. Like, if maybe in your testing framework you don't care, I mean, you want to explode if something goes wrong because it really isn't supposed to happen, okay, but otherwise you will always see this kind of error handling. Okay, Go as pointers. What do you think this function is going to print? You have two options, 42 or 21. How many of you think the function will print 42?
What is there before the p variable?
Before the p,
Yeah.
it's at the reference. So we start with an integer, and then we use the address operator to take the pointer of e. So p at line 9 is going to point to the value of e. And we are assigning something to that memory location. At the end, we are printing e. It is going to print 21. So I don't know if you have a C background or if you know about pointers. If you come from a C background, Go doesn't have pointer arithmetics, so it doesn't have that. But you have pointers. And I think this is the reason behind that, it's performance. Sometimes when you have huge amount of data, you don't really want to copy lists around by value as you do in functional programming languages with immutability. You really want to go to the memory location, change that thing, and go on. So Go as that.
Yeah. Might I suggest maybe you can go to system preferences, accessibility. There you have the zoom function that should override everything else.
Maybe you go out of full screen.
Let's try both.
In accessibility, you have a screen.
You fix the Mac.
Let's have a look at that. So font.
No, there is you can zoom the whole screen with that.
Okay.
I can't read it, so I can't.
Yeah. Zoom in, out.
Yeah, exactly. Exactly. Yeah, that one. So you can zoom a little bit. Yeah, right. Oh, that's fine. Now I can answer your question.
This was what I want.
And it's also better for the people who are online.
Yeah, nice.
Control and forward.
Okay. How can I go back like quickly to the older thing? Okay. Nice. Thank you for teaching me this. It is really an open discussion. Okay. Let's go to the 6th milestone then.
Zoom in.
Okay. Let me begin with the easy one. Okay. So in Go we can declare structures. This is we also have maps and arrays that you will learn quite quickly. But the way used to combine variables and combine things, it's structures. You can either have named fields like this ID of type string, and you can also have like embedded structures like this GPS structure. So this one appears up here, and then we have the GPS. And here you can see how I created this empty GPS structure. Here you can see another difference with other languages. We don't have Go doesn't have like built-in constructors or something like that. It is really in a way a boring language. You just have functions, structures, basic types. If you want a constructor, just write one, new item, ID string, and you return an item, and that's it. Let's see how we call it. Okay. So in the main function, which by the way is the entry point of every Go program, I didn't say that. And we have the new item, which is creating this new item, and we are here calling the GPS position function. Because the item has GPS in it, GPS has a method called position, and this is what we are actually calling. In the print function, we are printing the latitude, longitude, and precision that this function is returning. So let's have a look at the result. Okay. Cool. I would like you to pause and ponder a moment and take this method as it is for now. It is not really different from a normal function, but in a way it is. We'll see later. This is the basic building block for creating abstractions in Go. So just hang on a moment. We'll have a look at the other two milestones, and you will understand why. Interfaces are the way you abstract things, you create contracts between parts of your code in Go. So an interface is just declaring some functions that you expect something to have. Let's say in this case we have created an item, and in the previous milestone we used the GPS structure, the actual type, to obtain that position. But let's say, what if we want to mock that thing away? What if we want to provide more ways of getting this position for our item? So the way you do that in Go is you create an interface. In this case, I call that the finder interface, which describes the function that we are going to need in order to obtain the position. This time, instead of creating the new item with the GPS embedded in it, we are asking for colors to provide a finder implementation. And here, oh, good one. Beg your pardon for this. Okay. So we provide two structures that implement the Finder interface. And how do they implement the interface? They just have a method. So this is a function declared on a receiver. In this case, the receiver is the Find My Network structure and the GPS structure. They both provide a position, but in this case, with different precision. The new item, this time, we create the new item and we use the GPS implementation. But we might as well use the Find My Network one to obtain a different precision. Okay, so this is a little bit weird, I know, at the beginning, because we are declaring an interface. We are declaring what our item needs in order to get a position. But these two structures do not declare anything. There is no import, implements, there's nothing. They just have the right function. But if you think carefully about that, the compiler already knows everything he needs to know in order to know whether Find My Network or GPS have the function you need. And it is just position.
Sorry, but what is the difference between these two functions?
Well, in this case, pretty nothing. I just used a different precision return, so you can see in the output that this is different. But imagine that this is, I wanted to mimic the Find My Network from Apple. So it uses Apple devices to obtain your position. Okay. We either have, maybe in our system we have GPS available or this Find My Network, which will have a lot of things, I imagine, inside the structure, like a way to communicate with the actual GPS system, a way to do or in the Find My Network, a way to communicate with Apple servers and obtain the data. So here it is just a hard-coded value returned by the function. But I think it carries a little bit of the powerful of this abstraction. It was just that easy to create a new item function that tells, okay, you know, I don't really need a GPS. I just need someone who can get me my position. And that's it. And how you declare that? With an interface. You have other means of creating abstractions in Go, because you can also, functions are first-class citizens. Let's say you can assign an anonymous function to a variable. And of course, you can create structures that inside of them have, like you provide the function implementation for them. So for this position, we could have instead created a variable inside item that was a function, like pointers to functions if you come from C. And you provide, this time it is a function that is calling the GPS, this time it is a function that calls the Find My Network. But this is an idiomatic way of writing Go code and describing your abstraction using interfaces. Okay. We did not cover concurrency yet, but I already see you a little bit confused, and I imagine that it is not that easy to I think it is. Go, it is a simple language, but with that comes a lot of powerfulness. You can describe a lot of things with just this simple construct I've shown you. So as soon as this is I suppose, I imagine a kind of conversation between us developers. After this slide, we will have the open session. I've prepared an hands-on of a project I've written this morning. I've prepared a slide with the useful links that you will have absolutely to look at if you want to write Go code. And and I also have some slides about the actual Go project that we are running in production at our company, at the Keep in Mind. But if you have any question about the previous milestones, please, this is the right moment to do this. So if something really isn't clear for you, let's do it.
Is Go call by value or call by reference in general?
You mean like the receiver?
Yeah.
Okay, let me show you. Good question. No, it is actually a really interesting question. Because here, for example, the position is not calling anything of n, but n, it's the actual receiver of that function. So you have n available. When I create an instance of Find My Network, and I call position on that, it is exactly as we have written. Let's see if I can. Okay, I cannot edit that one. I can edit everything, but not the one I want to edit. Okay, yeah, I can edit this one. Maybe. This is the same as doing this. Okay, I cannot cut away the 8. But the compiler is actually translating the things like that. So the receiver is going to be the first argument that you pass to the position function. That argument might be a value or a pointer. So we can, let me see if I can go back to some clear state. Okay, we can declare it like that. And this means that the position function is going to work, is going to be visible when GPS is a pointer. So you can pass things by value, by reference, and it is up to you. The difference, the main difference, is when you use a pointer receiver, the function is going to be able to change, as we saw with the integer before, the values that that structure is holding. So this is what I usually start with without pointers. So it is clear to me that this receiver, this function, is not going to be able to modify my things, so the interfaces are more clear. But when I see a function that wants a pointer receiver, I already know, this means that this function, it's going to modify, or at least I have to be aware that this function can modify my structure. Usually in the documentation you see when someone declares it before, but you know that. You have to be aware of that. In this case, the position function is not going to ever be able to modify the GPS structure after it returns. With this declaration, it is going to have the reference in memory of the actual GPS instance we have, and it is going to be capable of modifying it.
So it's clear when you have side effects and when you don't.
Exactly. Other questions?
So you programmed Java for many years, you programmed Objective-C. Why do you prefer Go?
So Go, I think the features I showed you before at the beginning of the slide are really something that you really don't get for free.
Why do you think we should program Go?
I think you should, if I have to write a tool that I want to deploy to people, and I don't want to ask them to install nothing. I don't want them to care about anything. I'm just going to ship the thing to you, and you just have to run it. Go is really a painless solution for doing so. So this is why I'm using Go right now. Some of you maybe attended the last session we did together about the Elixir programming language, the hipster programming language. Actually, at Kim, we use Elixir for our backends, really, because the concurrency in there, the distribution that you can have, it's another level thing. It's like in the bare bones of Elixir, you have distribution. And this is something we do every day. Inter-process communication is not an easy thing to get. But if I have to ship a tool to the final customer, or if I want to write a personal tool that I want to use, I write that in Go. Because I don't want to bother with, you can have cross compilation with C as well, also with C++, but let's please don't talk about the language. But the thing is, it is way easier for us also in a company to share Go code, because it is, I think, pretty easy. Of course, everything at the beginning it's difficult, but after a while it really just makes sense. And it is with the only mechanism that you have of creating boundaries between packages and requirements. It's interfaces, which are really very simple to implement and work with. This is why I like Go, and I keep on writing Go, and yeah, I think Go is it's worth a try.
I think that so you are, I mean, you are saying you are motivating with portability, which is something that is also...
And reproducibility.
Okay. Right. I was just thinking about I mean, I think about Java. It was born with this, keyword, the portability and stuff. So I wonder what is really the difference.
I believe this is why Russ Cox talked like that at the beginning of the promo video, because Go natively cross-compiles. So you don't have a virtual machine between you and your computer. So I'm not going to. So in this presentation, you're not going to see any performance benchmark and stuff. But if you go into the internet, they have done plenty of that, and Go is way more performant than Java. So it is true that but let me pause a moment, because also Elixir is portable. You have the bin, you have a virtual machine. I can send you bin files and you just have to execute them. With Java, it's the same thing. You have your bytecode, you have this intermediate representation, but you need the Java virtual machine. I cannot just send you bytecode and your machine is not going to execute it straight away. Instead, Go, I really just send you the executable and you run that. So
but you need multiple builds then for different architectures.
You do, because exactly when you have the same code base, and if let's say I have macOS, you have, I don't know, your machine. If those are different, and I want to create a binary on Linux on GitHub, you just have to download and execute. I'm going to have to cross compile the application for every platform, upload them, and then everyone is going to see okay, Darwin for ARM, Darwin, and the different architectures and things.
And how big is because I say to him the problem of Java is Maven, no? That you get then 30 gigabytes of additional libraries for a simple tool. Is this effect also in the Go world, or do you have all small things without using libraries, frameworks, and this kind of stuff?
So Go takes a very lean approach, but the binaries are not that small because of the static compilation. So it comes with a disadvantage. You have to expect your binary to be, well, you know what? Let's move to the terminal section, and let me just show you.
Command plus plus plus.
I just created this project this morning, and in here we have one executable. As we can see, it is 12 megabytes. The executable.
You can do command plus plus.
Yeah. How about that? Readable?
Okay.
12 megabytes.
And what does it do?
So basically this, let me show you. This all, so this whole project is just these files. we have a AWS package, a common package with inside executable. The tool is just a simple tool that wants to take care of uploading a backup of your files for you. This tool doesn't allow you to upload things that are not encrypted. So in the upload pipeline, you're going to tell which files you're going to upload, in this case on AWS and in the disk for mocking. And the tool is going to take all those files, encrypt them in parallel, and upload them. And I use this mnemonic encrypt upload for the tool. This is one morning work, so don't blame me too much. And then we have the main package, the UPDO, so upload download package, with this store.go file upload test, which is not going to be in the final release. And yeah, the main executable uses some standard libraries of Go and imports the up2 package, the main package of the thing, because here we are within the main package, and the AWS thing. So just to first of all show you what this thing does, I've created this packet in AWS, which is called up2. We are just looking at the contents of the bucket, and we can use this tool to tell him the recipient. So because as I said, you have to encrypt the data before uploading it, and we are going to upload everything. Okay, done. Okay, this is what the tool does for now. And the idea is it uploads stuff, and when you want to download stuff, you just let's see what the contents are, because otherwise it doesn't make so much sense. I have to let's say encrypt. Okay, so we see it is an armored file of the contents encrypted. So that's it. It just does that, and it's 13 megabytes of stuff, which is pretty huge. I mean, it is a fairly small program, and yeah, I don't know if you're if we.
Does it become much bigger?
Yeah, exactly. How small is the hello world? Is it starting already
Let's do that.
10 megabytes? Because maybe that's the problem. There's a huge base cost. And then I have a question from the audience who is writing me through Telegram.
Yeah.
The audience is also telling me that double the code is not 24 megabytes. So it should maybe 12 megabytes is a basic starting point.
And then I put in the queue also my question, but after the public.
I have one.
1.8 megabytes.
Okay.
This is the Hello World program.
Yeah, but if you statically link C, it is going to do the same.
Exactly. That's the point. But you don't feel that usually, because most of the times you just have at least libc is going to be dynamically linked. In this case, everything is going to be bundled with that. In Linux, you would have LED to check that out. I don't know in macOS what you have, but that's it. You just drop that. And also, if we change the operating system, we can do the. Let's see whether I can do something like that. Last command was that one. We will hello win. Let's see whether there is a difference for Windows. Same size.
But you can cross-compile to every platform out of the box? No.
Oh,
I have
that's
a
cool.
question here.
Yeah.
I read it because I don't understand it. I'm a newbie.
Okay.
Go offers this wonderful channel communication paradigm. Is it finally possible to use it also for distribution, inter-machine communication, since this had been a limitation for a long time?
Just explain what it means. What
Yes.
the question means, please.
Allora, oddio, sorry. So we have channels, and I will here I open the main function of the tool you have just seen, and let's have just a look at what happens if I just run and stop. You see, it exits quite immediately, telling that the request was cancelled. And this is happening because I created a context. Don't be scared. It's, as always, it is just a structure with a channel in it, and I'm forwarding this channel, this context, to the function which is uploading, and the function is listening to the. A channel is a way we use to synchronize multiple Go routines. Go is the keyword you use to run a function concurrently. So here we create a channel of type OS signal, which has a buffer of 1. We then call the signal standard library and ask them to notify this channel when an OS interrupt happens or a syscall sigterm. Okay? So if our program receives some of these signals, it is going to send a message to this channel. And here you see the syntax we use to receive, to block and wait until something happens inside the signal channel. So imagine a channel like an in-memory pipe that and a synchronization point between two parallel threads of execution. Okay, so we have this Go routine which is doing its things, and then writes a message inside a channel. If the channel is not buffered, and this one is, it is going to wait until someone at the other end of the channel is listening. If we remove the Go function and we try to write and read in a channel within the same Go routine, within the same thread, there is going to be a deadlock, of course, because the code is going to be executed, you reach the channel, you push something to the channel and wait until someone is reading from it. But if there is no one concurrently running that is going to use that channel, you will just end up in a deadlock. So channels are this way of communicating. Let me just, before answering the question of our colleague, let me just show you how channels are used here to upload concurrently every file that we have in our the upload function is receiving all this named data, I call this. So it is those files. Each file we extract a reader from them and we assign a name which we will use to as a key to upload in our backend storage. Here we concurrently run the u.upload1 function with the context and the channel. This channel that we have created is a type upload result and as a buffering of the amount of data that we are going to, because we are going to call this function data len data times. So we expect in this channel to receive length data messages because of how the function is implemented. So the upload one function is going to it is going to read from the named data, encrypt it, and send it to this in-memory pipe. This I/O pipe basically pairs each write in this side with a read in this other side. This other side of the pipe is sent to the u.store.put function, which is taking the bytes and sending it, uploading them. So in this way, we are not encrypting and creating a huge buffer with encrypted data. We are just, it's like a back pressure. As soon as the uploader is capable of uploading stuff, it is reading from our cipher and taking the encrypted data and putting it upwards. So we use the channel then to send the upload result back. Okay. So all these functions are running concurrently. They use a channel to send the message back to the caller, which is ranging over the channel, reading the results and stopping as soon as something wrong happens. Of course, this is maybe a poor design, but yeah, this is one morning work. I mean, inter-process communication requires more processes that run maybe in different contexts. We just cannot use channels for that, because channels are something that live. It's just a shared memory location, and we just cannot share memory between other operating system processes or processes that live in another machine. Maybe we can, but at that point, I don't know whether the control that you have using channels it's enough for building something like that. I mean, if we have to do inter-process communication, you have plenty of other solutions for doing so. Channels, I think it's not one of them. Yeah, I would answer like that. Because they are meant to be run within one single process. So we have our Go program, which runs many Go routines, and that can communicate using channels. We have also semaphores, mutex, and the usual stuff. But channels are the idiomatic way of synchronizing.
So it just works in a single process, but not inter-process.
Exactly.
Okay, so just to be sure, this is single-threaded still. It's like async in JavaScript. It is an abstraction, but it's still single-threaded, right?
I mean, your program can use multiple threads,
Okay.
but can also use one single thread, because concurrency at the very end,
Okay.
it just interleaves executions.
Okay, if I use channels, it's still single-threaded. If I want to program something multi-threaded, I need to explicitly do so, right?
No, it depends on your machine. So if your machine is single-threaded, it has actually one, let's say it has one core. You are not going to do multi-threading in the real way. But you're going to write the program in the very same way.
Okay.
And it is going to look like it is doing a real parallel execution, even though it is not really doing that.
But it can use multiple threads if the...
Exactly. If your machine is a 4-core machine, you are ensured to use all 4 cores. You can also profile that and have a look at that, and it does the job. Of course, if you are talking about really high performance computing, even though Raskog said it's super fast, at the very end you want to have control over the memory, and in Go you don't have that. And you also have at runtime, saying that Go is a runtime is like, it is not really true, it is not really a virtual machine. But when you start your program, you have a process, a Go routine that does the garbage collection for you. You have some things that are more than just your code. So yeah. Okay. So eventually we have also seen how concurrency is done here. As soon as we have talked about inter-process communication, I would also like then to show you some, I did some scratches of the architecture of some programs we have in production. And in this case, for example, we have inter-process communication. And I don't know if the Zoom is going to help in this case, but
it helps people online.
Okay,
to
nice.
see better what you are presenting.
So let me just present you these 3 projects that we have in production. This one is up from 2018, and we didn't have to do like anything on it. Its use case, it's basically we have a stream of let's call video chunks, that you want to merge together to create a single MP4 file. So the cutter uploader does just that. We have another server that is going to collect the metadata and say, okay, from this chunk till this chunk we have a Lord of Rings. You have to take that, cut it, and make a single movie and upload to that location. So it will put, in this case, we used RabbitMQ to do inter-process communication, and also to ensure us if a cutter or uploader crashes or dies in a really unexpected way, this job will not be lost. It will get back to the queue, and as soon as we have a worker that resumes doing the things properly, it will pick the job again and operate on it. So we have created these two executables. One is the cutter, the other one is the uploader. One is reading from the cut queue, doing the actual cut, and putting the next job in the upload queue. The uploader is going to pick these tasks from the upload queue and upload the messages. So this is one of the use case we have, and yeah, we are pretty happy with that. The other one, for example, is a recommender system that, I did that again. Oh, look at that. Okay, found another accessibility feature. The recommender does something a little bit different. So we have this database with the that collects metrics of usage metrics. And the recommender is polling it for updates. When it sees another window of updates, it computes the new recommendations for each user. And then updates the affected files. In parallel, we have a file server which is answering the recommender requests for each user, picking the most recent recommendation and sending it to the clients. This is another use case we thought like would be good for the job, and it is. The last one is like pretty new, and this one is doing live transcriptions. So it is receiving from AWS Media Live an RTMP stream of AAC audio, continuous. This program called LiveSub is taking the audio, cutting them into windows, transcribing that content using different engines. So this is a good place where like interfaces were good, because at the first day we knew that our customer wanted to try AWS engine, Google engine, IBM, every one of them. So we had to create a cool abstraction, and that was a place where it was very easy to do so. It makes the sentences out of the transcribed text and exposes a live editor that many people can connect to and like receive the sentences that the tool understood from the audio. It provides a live editor that professionals use to correct the sentences that they don't want to end up in the final stream. And LiveSub is taking them back, creating queues, creating the M3U8 playlist, and uploading everything to the AWS S3. So these are 3 tools that we use. Internally, I've built a lot of small tools. For example, this Temple one. It's a template program I use, for example, if you want to create a new Go project. Usually we need a specific, maybe makefile, Docker image to upload that. If you want to create a task definition out of it, I don't know. We have different use cases based on the final, the end product that we want to create. And so, for example, internal tools like that, we write always them in Go. So it's easy for us internally also to distribute them. Okay, so
one question: how do you, because this looks all like backend stuff, how do you make the user interface for this? Do you have websites that connect to Go? Does it have a REST interface, or how do these things communicate?
Which project are you talking about?
You have Go that does.
Usually, you write Go used mostly just in the backend, and for example, it exposes a REST interface, GraphQL API.
JavaScript HTML.
Yeah, you do have a lot of projects like Gene. You have web frameworks. You have yeah, this one I've never written a single line of code with it, but you can use that to create APIs, and also it supports. Well,
Is HTTP in the standard library? So to serve an HTTP request, is that built in?
yeah. So let me. This is the place where documentation lives. So previously it was called GoDoc, and I still keep on using that. I write GoDoc and the package, and you end up in package.go.dev. But yeah, you have everything basically. We can also have a look at the standard library if you want to. We have the net package for doing HTTP servers. We have crypto. They have a very good team that does that just concentrates on crypto. We have some Go, some database management interfaces. We have a lot of encoding, yeah, hashing, HTML, templates, image processing, mathematics. Yeah. Quite a lot of stuff in the standard library, and actually I think I mostly include just stuff from the. You can, let's say, without relying on open source projects or other things written that are not included in the standard library, you can basically write anything because they've implemented much of the protocols that you would like to have, and the networking stack, it's pretty complete. There is another notable Go project that I wanted to show you. It's called Tayscale, which I eventually didn't include. But for example, they are building this VPN that, okay, let me show you just with Tayscale, without Tayscale. So it uses, it is like a peer-to-peer VPN, where you just declare which servers, which endpoints are connecting together, and yeah, you don't need gateways and other stuff. So they are doing hardcore networking, and they are doing that in Go. And they also provide the VPN for iOS. So you can also bundle, as soon as you have native cross compilation, nothing stops you from bundling Go inside an iOS application and creating a library from that. They are doing it, and they have plenty of blog posts about that. So you'll find Go in many different places. Okay, there is one very last thing that I would like you to take home, and then I call it like an end. The presentation is open source on my GitHub page. So afterwards you will have a chance to get all these things. Also the other tool. No projects, please. Okay. So here you will find the slides inside. So if you have to take the links and other stuff. This is the former GoDoc, where you find the documentation. Goland.org is the official website. And this one, it is really the first thing you will want to read if you're going to write Go code. They explain the language in a very. They show you how the creators of Go would implement things, how they use the things that they have created. It is really condensed, simple, but if, for example, you don't know about interfaces, you go there and they have a little talk and they explain you why did we create interfaces, how we use them, and stuff like that. Okay, then another Russ Cox, the guy that I show you at the beginning of the video, it's one. it's a tough guy. It's one of the hardcore ones. So if you want to have sneak peeks of the decisions of the memory model, of the versioning, packaging, how they do proposals, this is not only about Go, but programming in general. And I highly recommend you to have a look at this blog post. The other one thing that I found pretty useful at the beginning is the tour of Go. This is an official thing from Goland, and here you will have a chance to use the playground as we did during the presentation. And they have exercises and also different like steps to learn things that for example, I did not cover, like flow control statements. You just saw some if statements and for. But before writing Go code, I think it is useful to have a look at this one. And the playground. This is also a resource that I find pretty useful. As we did during the presentation, you can use the playground to write some code, and also they create some permalinks you can use to share the playground with someone else. I also find it useful when sometimes maybe I'm in a large project and I just want to, for example, slicing. When you use, when you create, let's say, a list. Okay. Okay, let's do something like that. In Go, you can do like sub-slicing. For example, I want to take elements from the beginning till the second one, and maybe I'm not sure, is it going to take 2 or is it going to take 4.6? Okay. And then you have the answers pretty quick, and you can also share the thing. I find it useful, and yeah, I wanted to give you this advice. So, for me, that's it. Yeah.
Since it's Google, I was expected after 6 months you have breaking changes.
No.
What's your experience here?
Yeah, they did it for many other projects. That's true. In Go, instead, they promised, like one of their first design decisions, they promised that the language is not going to change. It's like frozen. And the first promise they did is that like you will always be able to compile the projects you've written like 5 years ago. No problem, even with the latest Go version. They are very careful at adding stuff. Like it's an open source project, but very, 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 very few features end up in the actual language. This is also something I appreciate. I've been also coding in Swift and in the Apple's language. In 4 years, like we have seen a complete rewrite of the language, and a lot of that mess was pushed to us developers. In Go, this didn't happen in like ever, and I trust them. I trust they are not going to change this way of thinking. The language doesn't include anything. The biggest change we are going to have now is generics, and they have been talking about that for like 5 years. And it was one of the main features that was missing. If you look at the math package or other packages, as soon as Go is pretty strict at type conversions and makes you like cast types, even though it is like if you put your mind inside the compiler, you say it is obvious that this is a conversion. The Go compiler is pretty strict, and so some code is pretty verbose, but really some side cases. But this was the last flexibility thing they wanted to add, and it is going to be generics. But yeah, it was a tough decision for them.
So, I have a question, but it's more a curiosity.
Yeah.
Because in the past days, I had a look to some documentation of Go to look to know better the language. So because I was not knowing it, since 6 months ago, and I've ended up to an article of a guy that was trying to make IoT applications using Go. So I was a little bit surprised because on IoT devices, resource and memory management, battery management, it's quite an important thing. What's your opinion? Is Go a language that can be used also in these use cases, or is that guy completely crazy?
I mean, I've seen. It depends on which type of embedding you mean. Because if you have an embedded board that runs Linux, I mean, having Go inside of it, it means, let's say, Linux without any real-time constraint, or just something like your smart garden or something like that. And you have actually maybe an embedded device that just runs the application you're targeting. In that case, I would say yes, why not? It is. I think the project is called Godot or something like that, GoBot, and I think that they use a kind of different compiler. I have to check, but if I recall correctly, you are not allowed to use channels, for example, because they were a little bit difficult to implement in that constraint environment. But I mean, if you need full control over your device, for sure Go is not your choice, because it has garbage collection. It has you don't. It is there are things that happen behind the scenes that are not clear to you. So this is why I wouldn't pick that. But if you're not really interested in real-time constraints, if the memory is actually not really a problem. I mean, if you say, I'm doing an embedded project and your board is a Raspberry Pi, I mean, Go, it's pretty good with it and no problem at all. That would be my thing. If instead you're using a microcontroller with a very reduced instruction set, the options you have are really, you wouldn't think about compiling Go from there to the controller.
No, I completely agree with you, and I think that for embedded systems, if you want to have the full control, maybe C it's the better one. Or
yeah, sometimes you have to dig even more down.
What about EDIS?
EDIS?
ID.
IDs. Okay, I'm not an ID guy, but I mean, Vim might become a pretty huge ID, and you have this Vim Go thing. You can use that extends Vim if you are a Vim guy. Otherwise, Visual Studio Code has plenty of support for it. My usual flow when I'm writing Go code, I just write the code, then I get out. I mean, you don't even need so many tests, make files and other things. I just exit my session, resume it, write some more code, exit. This is my iteration flow, and I'm pretty happy with that. Also, the syntax is not that verbose too. So also auto-completion features and stuff. I don't really. If I write some Java code, after a while, I'm really typing too much, and in that case, I really need something more. With Go, that problem didn't arise for me. So. But yeah, you have a lot of support for every ID ever. Even though it looks like Go, it's not that popular. It appears here and there. I just wanted to show you another tool, so that I see that the tests are cached. So let's change the source code a bit, so they are going to run again. Go comes with a lot of tooling for doing stuff. For example, formatting the code base. Here it just shown the files it has changed. Usually it organizes import statements, makes the comments a little bit prettier, and it's not that doesn't cut lines in the middle of them. I don't. I've never had to look at formatting configuration because I didn't like the way the formatter was changing the code. So, okay, let's test them again. You have this test package included. Yeah, you just have to import testing, and then, for example, this is the test for the upload thing, which is mocking the storage, which is when we ran the program before was AWS. Instead, now that we are for the tests, I prefer to have on disk implementation, and this is just the store interface was just declaring this function. So to mock that thing, I just had to add this function to my disk driver, and yeah, I was able to call the upload function. Yeah, created the uploader with the disk instance instead of the AWS one. Yeah, so you've seen also that we have go test, go build, go install, that compiles the binary and puts it into the go bin location. See, yeah, I don't know what much more to say. Any other curiosity, doubt, thing?
If nobody's asking, in other languages, you start to get this kind of, I just glue together other people's code. You have Maven in Java or NPM in JavaScript. Is there some such thing also in Go?
Yeah, it's built in the compiler toolchain, and it's called Go get. Okay. So to import code, let me show you the thing you need to. Let's see the AWS package. Okay. Here I'm importing all these things from the AWS SDK, and the way you import them, you just go get and github.com/AWS, and this is actually a path. So Go had this thing at the beginning of the Go path. It is the root of your project, and the idea was you are going to, let's say your GitHub name is A. You would put your code inside gopath/github.com/a/youramazingproject. Okay, if I'm going to import that, I'm going to do go get github.com/a/youramazingproject, and this is going to end up in my workspace at the root of the Go path. When I'm building it, it is just like as you are doing, okay. But for me it was an imported library.
Okay, but it imports source code, basically.
Yeah. Okay. But with this had a drawback, and at the beginning it didn't have versioning. So it was really like copying your code, but keeping like a file system structure the same for everyone. So it doesn't have there is no difference between a library that you have imported and a project you are working with. Okay, but with Go 1.11, we have this Go mod thing. And this is going to take the version, either you specify it or it infers it for you, and this is going to create in your Go path a mod folder with every specific version of the code you want to import. And in Russ Cox's blog that I showed you before, he's talking about that extensively. So afterwards you can update the code, update the libraries you are using, and everything, and all is controlled by this Go 1.1 module thing. If it is auto and your code is living inside a proper Go path structure, then it is going to use the old way of doing things. If instead I give you a folder and you just put it in your desktop and you don't set any Go path, so that the file tree doesn't make any sense, the auto will default to on and will use modules by default. Essentially, you want to ensure you have a module instantiated when you are going to deploy code. But if for example you are maintaining a library that you are using, you want to disable this feature, so then you don't have to release a new version of the library just to, I don't know, enable some more logging or change a feature, test a feature in your code that is importing the library. Otherwise, it would have to create a module and stuff. So you have Maven, Gradle, those things integrated in the Go thing. This is going to disable static linking. Not completely, but you can link dynamic things. I've never had to use Go and C together, but if you have to, you can. Yeah. Any other question? Did you like the language? Like the syntax? Was it a little bit cryptic?
It's nice. It's cool. I like it.
Okay, good, nice. I like it as well. I think it's clean, like not many things, but with a lot of flexibility and power. Okay, then for me.
Okay. If there are no other questions, I really.
Please.
No, there is one.
My question is, which kind of you have with Go right now? Like after your, I don't know, maybe years of experience, you have more experience about Go. You have a problem, and right now, which problem currently you have? You can do this stuff, or this doesn't work as you expected, something like this.
This is actually an interesting question, and actually this project that I've shown you today, it's one problem that I think Go would be perfect with, because I have this friend of, well, the father of a friend of mine that was hit by WannaCry ransomware, so he doesn't have any data, and he asked me, what do you do to protect against these kind of things? And I told him, well, you don't protect yourself of these things. You have to be in a condition where if your computer like burns, you don't care. It doesn't matter. Your data is safe. You protected it beforehand. So backing that the things up and having like backups of your data, it's important. And I wanted to do a proof of concept, like a very small tool you can use to upload your data. For him, he's an architect. It was important like that nobody is going to be able to read projects that are not released, because yeah, it would be kind of a problem. And so I thought, well, let's build cryptography built in. And for this kind of task, perfect. Let's go with Go. This is one problem. I would go for it.
Anyone else wants to know something more? Has doubts, questions? Seems not. So I will thank really a lot you for this nice presentation, this nice introduction. It was really interesting to know more about Go. And so if you can share with me the links of your GitHub, so I can share it with everyone. And then I want to remind you that November, it's a full month for us. The 12th of November, we have the SFSCon, the Free Software Conference here at Noi. We have still some free places. Please, if you are interested, you are welcome to come. The same day will begin also a hackathon. If you are interested, maybe to make 24 hours hack with Go or with other, or you have ideas, we have still free places. Please subscribe you. It will be really interesting to have you here and working and hacking one full day. You can go on hackathon.bz.it and you will find all information. Then the day after we will have also an Uniro workshop connected to the SFSCon. And the next month, the 2nd of December, there will be the next Software Developers Thursday. And there the staff, Südtirol Transport AG, will present what they did with open travel and their services and open source software that they use to improve the services that they provide to the citizens. So these are the next appointments. In the next day, I will share with you the link to the presentation and the GitHub repositories where you can find the material that has been presented today. And thank you all for coming, and I hope to see you at the SFSCon and at the hackathon.
Thank you. I would also like to thank Stefano, because he was the one organizing and calling and taking care of everything. So thank you, Stefano.
It's a pleasure. So see you soon.
Okay.